right now I'm going to record my discussion post, and the problem states that for the cash flow below, what is the equivalent amount at the end of year 0, end of year x plus 2, end of year n, for these conditions? So I'm going to start out our given. Our A is I is going to be 10%. And that is quarterly, compounded quarterly. We have to get our effective interest rate. And to get our effective interest rate, if you look over here at these different terminologies that we were given, you're going to want to do that for IE equals effect. Okay, so that tells us what to plug into Excel. So this is, and then you go under financial, to go to effect. The nominal rate is going to be this value here. Since this is the annual, like this is the nominal rate, but it's annual. And then for N, that's asking how many, if you click right here, it tells you the number of compounding periods per year. So since this is quarterly, it's going to be compounding 4. Okay, so that gives you your effective interest rate. We want to list our N, which would be starting out as 6. And you'll see that here in just a moment. And for part A, we're going to find out what is the value when x equals 1. Okay, and then B is when x equals 3. Okay, so that area, let's see. All right, let's go ahead and solve for A, or start working on A. So we have basically 0, we have x, then we have x plus 1, x plus 2, x plus 3, x plus 4, and x plus 5, which is also N. So we want to see what those values are for the year, for each year. Okay, so that's still going to be 0 here. And then what we're going to do is x equals, for part A, that's going to equal 1. And right here, we're going to say x plus 1, so that would be equals to 3 plus 1. And then we're going to say 2. Pretty sure there's faster ways of doing this. I'm just making sure that I get all the numbers in there. Okay, so this is, now we're left with our years that we want to focus on. And so for all of these years, starting at X, there's a payments being made of $2,225. And that's the same for every year. So now we need to know what this equivalent value is. And we're looking at the end of year 0 and the end of year X plus 2, end of year N. Well, that places at end of year 0 right here. End of year 3, and then end of year 6. All right, so we need to look at each formula, the formula that we're going to be given for each one of these, and think about how we'll solve for each one. So let's say, let's put the formula in here. All right, so for looking at this one right here, for at end of year 0, we know A and we're trying to find P. So that's P given A, and we want to know the value of that. So what we're going to look for is this PV, all right? Go to the financial tools, PV. All right, we're going to use this effective interest rate here for rate, for N per. We're going to use 6 because it's a total of 6 at that point. And then we're going to make sure that we use this value up here for A, but we're going to make it negative. Okay, so that's the value at the end of year 0. So let's look at this one right here at end of year 3. We are looking at the future value given P, where P is actually this value right here, okay? Because it's like an intermediate step. So if we were given, once we find this right here, we'll use a different formula. But for this one, we're going to use this, the P value at 0. So that would be F given P. We're going to look for the FV, and we know the rate. And then in this situation, for the N, we are going to look for 3, because this is 3 from that value, okay? And another thing, if we're given P, F given P, okay, it's wanting to know the payment amount right here, but we don't want to give that amount. We want to give the future given this value, okay? This amount, this PMT is more for the for A. Okay. Oh, and I forgot to make that negative. And that'll make it show black. So for this one, for the end of year 6, that would be your F given A, because you're looking at the total amount over the full 6 years. So in this one, we're looking for future, and the rate is going to be the effective rate interest rate here. And in this one, we're taking the whole thing for N, so that's going to be 6, or value here. And we're taking A, since we know A, we can use this one. Okay, so that is part 1 for A. Okay, so for the second half of this, for part B, we're going to have a very similar type thing, but it's going to be shifted. So let me go down a few lines here and do this. So we're going to have the same thing that we had here on this end. And the difference is that up here, you have to look at it a little bit differently. So for this one is going to be at X, that is going to equal 3, which is this number up here. And as you see, it's just going to continue on. Instead of typing all that in, it's just going to keep going in the same thing, because it's only increasing by 1 each time. All right. So what you have is X equals 3, and then this ends up being actually year 2, year 1, and 0. So what we're looking for next is the amount. And the amount does not stay the same, except that the amount doesn't start till 3. Okay, and so over here, down here at 3, where we were at before, that is going to be, we need to find this value here. So that would be the equivalent of what it was at 0, okay? That was in the first step. And that would, so for this one, we're going to be using the same formula as we did before. It's P given A and in this situation we're going to use the same exact formula. And so we're going to use the under financial, we go to PV. The rate is given here. The end on this one is going to be 6 because the dip from here to here. So it would be the end of that and then to 6. And your payment is going to be this value here, but it's actually going to be negative. And you end up with the same value as this one at the same location. It's just that it's actually going to be shifted. So what we want to do now is, since we've got this value, the real place we're looking for is at end of year 0. So that formula is going to be a little bit different. So once we found this, the P given A, this is going to be more like P also like P 1 or something. Just give it something different. And given, and it's going to be, the future value is the same as the P for the previous step. So in that case, we're going to be using the PV the same rate, but this time it's going to be reduced by 2. So we know what this, so since we're finding the end of year 0, which would be right in here, that will be using value 2, and we're actually going to be using this FV since we're looking, because this is given F, which is this P, so it's going to be this number here, and if you make that negative, you come up with it'll be in the black. And then for, since we're still looking at x plus 2, okay, that is going to be end of year, that's going to be the end of year 5. We're wanting to know what the future value is given P. So we're going to use this P value, since that's at a 0, and then we're going to go all the way up here to 5. So that would leave us having the N at 5 in this case. And since we're using the PV, you'll plug that in here. Okay, so you can see that this one and this one are the same. And this is going to be the end of year 8. We'll be using the F given A on this one, and now in this case we're going to use 6 because the payments are spread evenly over, this is for 6 years. Click up here. And our payments are negative B2. Okay, so this is how you work both of these problems. You just have an intermediate step on this one on B. Right here to get this, since the equivalent at end of year 0 is actually slightly shifted by a couple years. So, all right, thank you.